for this lab, for this, chapter 16 lab, we're going to be doing the speed of a wave along a spring. So we have this helical spring, kind of like a slinky, and what we're going to be doing is we're going to be standing at 2 different lengths, and we're going to try to build standing waves, a certain number of standing waves at each length. So I need someone to help me demonstrate. All right, Kenny, thank you. All right. So we'll start at 1 length, and we have our measuring tape on the ground here, so we'll be able to measure to know how far apart we're standing. So let's say this is 8 feet. For the next one, for the second part of the lab, you're going to move it to 150% of the length, or 1.5 times the length that you were just at. So if you were 8 feet, then for the second part of the lab, measure it and you'll move it out to 12 feet. So let's say this is 12 feet. As you see, there's much more tension in the spring. We're pulling it further apart. So the further apart you stand, the more tension there is in the spring. So let's say that this is our first one. So what we're first going to try to do is we're trying to do 1 loop. So you're going to keep it still, and I'm going to be the one who is moving up and down. Sorry, not 1 loop, but 2 loops. So we're trying to build 1 standing wave. So something like that. So hopefully that looks approximately good. So what you have is 1 standing wave, and there should be a node right in the middle. So the node is the point that doesn't move. So what it should be looking like, hopefully something like that. If I demonstrate it, just hold that for a second. What it should be looking like is, you should be trying to build this, where you have a point in the middle, and then the 2 sides moving up and down. So that's our first experiment. And we have a stopwatch, so we're measuring the time for that pulse to make, it says 3 complete vibrations. So what you'll be doing is you're going to be measuring the amount of time it takes for that wave to go up and down. And then the next step is to try to build 3 complete loops, and then we'll move on to 4 complete loops as well. So we're going to try that now. So Kenny and I will see if we can make 3 complete loops and then 4 complete loops. So this is, where was I? I was about here. So let me see if I can make 3 complete loops now. So you're just holding it straight. So I have to ascend it a bit faster. So you see how there's 1 coming in the middle? So it's kind of like 3 loops now. So we should have 2 points in the middle, right? So that's 3. And now to do 4, you're going to have to do it pretty quick. So you hold it still, and I'm going to try to do it pretty quick. To send 4 loops. See that?
Yeah.
So remember that one person's going to keep it still, and the other person moves it. So yeah, we try to get 4 loops. And as you see, they move a lot faster. So let's do another demonstration of just stretching out a little more. So spread a little more. Alright, so go back. And now if we do 2 loops, something like that. Huge wave, right? Wait, I gotta keep. Alright, there we go. See that? Huge wave. And now to try to get, I'm going to try to get 3. So again, I have to move it a little faster. So something like that. You have to keep it going at a constant pace. There we go, something like that. And then if I want to do 4, it's even faster. Oh, that's like 5 or 6. Anyways, you'll play around and you'll try to get the correct number of loops. And then you'll see in the lab that they ask you to measure the frequency. So remember that we have period is in seconds, so frequency is reciprocal of that. Loop length, so if you know how far apart you're standing, and if you have 2 loops, then 1 loop is just half that entire length. Wavelength is directly related to that, and then wave speed, meters per second. So if you have wavelength, and if you have frequency, remember the formula that wave speed is equal to frequency times wavelength. So you'll do that for both parts, and then you'll test that. You'll test your experiment against each part, and then that's the lab.